So we're kind of hanging out in Bone today. I'm just cranking these babies out while I have a quiet house. I feel like I'm running out of time. It's all good. Hopefully I can squeeze this lecture out before the guys come back and make a bunch of noise. We will see. Anyway, we just had kind of a quick lecture on bone formation, but I wanted to stop there because I didn't stop. I just hit record for another lecture because this is chapter 6, lecture 4. I just wanted to kind of break or let you guys have a break, even though it's all the same repeating structure of bone formation. And I want to go back to that wacky little document I made. Oh, come on. Nope. I'm trying to get out of it. Oh, we can keep them. That's fine. I'm trying to go back to this guy where I said, hey, by the way, anything with bone formation, bone growth, bone repair, it's all the same. If I ask you a question, you can pretty much use this pattern, this template of bone formation as your answer, right? For bone to form, I need a hyaline cartilage model. These cartilage cells, chondrocytes, will come in and lay down cartilage, lay down hyaline cartilage. And that's the model that will ultimately be used by osteoblasts to lay down bone. So hyaline comes in, says, well, this is what I want you to look like. I'm now going to die off and form little pockets where you osteoblasts can come in and you will lay down spongy bone. Remember, osteoblasts are hanging out in the periosteum and even in the endosteum, in the linings on bone, waiting for yay, I get to do something. And they will lay down spongy bone. That's not always the end of what they do. They'll then have to fix it. And fix it is the osteoblast will convert that spongy bone to compact bone and lay down a nice regular pattern of an osteon with the solid matrix all in those nice rings and the canaliculi gaps so that osteoblasts become osteocytes hanging out in the lacuna. It's a little home in an osteon. And osteoclasts have to go, yeah, osteoblast, that was okay, but I gotta fix it and make it pretty. And we're gonna see more of that fixing it and making it pretty in today's little lecture. If I can kind of, I'm wondering if I can, give me a second, guys. All right, forget it. I cannot. Okay. So this lecture, we're going to talk about two things, growth in length. And this is kind of complicated because this book flips diagrams around, and then growth in the thickness. So let's see what we got here. All right. So when we look at a bone in that metaphyseal region, I don't know, I just made that up. We've got the epiphysis here, right, which is spongy bone. That's not growing. We have the covering around the bone, that articular cartilage, but then we have this whole area here of bone growth. So I have this zone of resting cartilage. So the cartilage cells aren't doing much. I have this zone where cartilage cells are dividing, proliferated cartilage. I have this zone where cartilage cells are dying out, and then I'll have this zone where it's calcified and actually it's osteoblasts laying down bone. Now see how these are the layers here? I want to see if you can kind of even see that. So first I want to point out why this picture makes me crazy. This has the zone of resting cartilage more proximal, but then here they flipped it around. So this is the resting cartilage, which was that top guy. This is the proliferating cartilage, which was this guy. Then the cartilage gets hypertrophic, misshapen, starting to die, and that was this blue guy. And then The white guy is calcified, and this is all at the epiphyseal plate. You see, I need cartilage there in order for bone to form. Now, I want to see something. Okay, I kind of have the same picture. The other thing I want to show you is if this was kind of the bone, you can see that it grew out a little bit. But I don't really want to show that. Yeah, I guess I do. So I leave this zone of resting cartilage. He's just hanging out there. He's not really doing anything. He's hanging out because he's going to be a source of cartilage cells. And oh my God. Stop. Ugh. All right. He's hanging out. No, he's not hanging out because it's not going to right. Okay. These are cartilage cells, chondrocytes, hanging out. So as these guys that are proliferating, that means they're dividing. They are pushing this knob outward, okay? So they're pushing everything outward as they divide, and then what was dividing cell will now become hypertrophic and starting to die, and then I will have the calcified where osteoblasts will come in and lay spongy bone. Nope. All right. I'm just going to let you know that that says spongy bone. So it's pushing it outward, and I'm hoping this is a later slide because where it used to be kind of knobby down below would make it keep growing knobby, right? As your bone ends are growing and growing. But that's not what happens. I have a region here that used to be the knobby end of bone, but it's no longer there. So I will have some osteoclasts come in and fix it. Let's see. All right, so I have the epiphyseal plate involved in growth of length. If I don't have cartilage, I don't have growth. Growth of cartilage on the epiphyseal side, replacement on the diaphysis side, so it's pushing upward. And when it all becomes bone, growth has stopped. And what I do want to say with that, remember we already talked about estrogen in women. Estrogen in women seal up the growth plates. That's why girls typically stop growing sooner than guys, because their cartilage becomes bone sooner than guys. So that's not a benefit. What is it? A cost of being a female is our growth plates seal up quicker, but we need that estrogen to keep our osteoclasts at bay. Why don't guys have as many issues with osteoclasts as girls? I don't know. So estrogen, oh brother, keeps this osteoclasts under control. So it's kind of a double-edged sword. I don't know. It's a kiss and a slap. I guess we'll say that. Estrogen kiss. Good job, osteoclast. Knock it off. And then it's a slap because, hey, you have to stop growing sooner. Oh, so here's just all the words of what we already talked about of the resting zone on the epiphyseal side. And then it grows out. And as it, stupid picture makes it very confusing because it flips things around. The older stuff is on the diaphysis side. So near the end of adolescence, they are dividing less often because you're not growing as much, and it's closing sooner in females. But, okay, here's what I wanted to show you. So this is kind of showing as I have bone growth. The dryer's going off. The emails are happening. This is what I was trying to show you. So if this was the pre-growth, before bone started growing in length, and then this is the post-growth, So bone is longer. What it's showing you is that this epiphyseal head area used to be down here, but now it's up here. So there would have all been bone in this zone. And I need to have that bone not be there. Otherwise, I'd have knobbier and knobbier and knobbier bones as I grew taller. So I have reabsorbed it. That is osteoclast activity. Okay, osteoclasts have to shape the bone. Oh, son of a biscuit. They shape the bone the proper shape. They fix it, make it pretty. All right, and it was also, bone here has been resorbed. Bone that was here has been resorbed. So there was bone here because I have to reshape where it's shaft and where it's epiphysis, and bones are growing in both directions. So I'm going to have osteoclast and osteoblast activity to lay down the compact bone, right? Osteoblast. Lay down compact bone. Oh, son of a biscuit. You little stinker. Like my little song. So they also fix it. Because what used to be spongy bone has to be compact bone now of the diaphysis as it's pushing the ends out. So it's pushing out the ends. And that's what that other diagram shows you horrifically because it flips top and bottom, pushing out ends. This is very complicated stuff. I'm not going to kid you, all right? It's complex, and I really just want you to have that basic understanding of cartilage in the growth plate, pushing out the ends, staying cartilage so I can continue to grow, and then the whole aspect of laying down spongy bone where there was cartilage, and then fixing the spongy bone into either reshaping it and reabsorbing it by the osteoclast or making it be compact bone by the osteoblast. See, I'm using those words a lot, osteoblast and osteoclast, and I'm kind of nervous because I don't know if you guys are getting it or not, because I'm just looking at me talking and pictures. So it is complex, and this is what blows me away. Bone homeostasis. You recycle your bones each week. Spongy bones being replaced pretty much 3 to 4 years, and compact bone, I think I even said every 10 years. That's nutters to me. And then I get older. So once we're all done with growing, because we're an adults, I'm not going to pause this. I'm going to continue on. I haven't been talking that long, so I'm going to maybe group all these two together. Your bone is constantly saying, hey, what's going on? What's going on? Oh my gosh, you changed your job from being an office worker to now lifting furniture. And you're putting stresses on your bone, and your bones are kind of bending, and I need to fortify and strengthen that. Or, oh, hey, you used to be working out with weights, and now you stopped. So your bones don't need to be as solid. It's going to go both ways, my friends. But this whole assessment of what's going on with your bones, it's constant with these osteoblasts and osteoclasts. They're like, okay, I'm ready. What am I doing? Am I going to build bone? Am I going to have reabsorb bone? But they're going to go back and forth on that. And it is all due to, so bone deposit, osteoblast. Bone resorption, breaking bone down, osteoclast. Because these guys are hanging out at the periosteum and the endosteum, right? Those are where osteoblasts and osteoclasts hang out. Hang out. So they're always poised and ready to roll. Poised and ready to act, we'll say. Not. Okay. And they are remodeling units. Okay, so what is this showing me? Bone formation. So Yeah, right. As an infant to as an adult, your bones are going to be a lot bigger, a lot thicker, and they're going to be growing in both directions. I don't have growth in width. I don't know. This is just pretty easy. Osteoblasts are going to make bone matrix on the outside as that, I guess, as this medullary cavity that was here is moving along through growth. I'm going to have the bone being munched up by osteoclasts as it's going outward, and the osteoblasts are making bone. So the osteoblasts are going to grow the bone in the outward direction, and the osteoclasts are going to keep that medullary cavity formed by munching up bone. I guess that's kind of a cool picture. Usually more building than breaking down. That would be a good thing. There are some disorders where osteoblasts get a little wonky. That's called Paget's disease, and it can form some pretty unfortunate blotches of solid bone on skulls and body parts because they're a little crazy. Okay, so is that all I really had to say? Okay. Factors. So I'm going to have bone be growing and remodeling based on a couple different factors. So what we have here, I want to see, okay, the mechanical stress is what I like to talk about, but we'll go through these other things. What's going on with your hormones? Do you have a growth hormone and interstitial growth factors to stimulate bone growth, right? If you are deficient in growth hormone, you're going to not be that large. Or if you're overly sufficient, you're going to have gigantism of growth hormone where you make really tall, large people. Growth hormone is a hormone that is coming off being made in the anterior pituitary. So if you have a pituitary disorder, and that's in your brain. You could have a growth disorder. They do make artificial growth hormone for people. In those cases, you just want to get it quick before the growth plates seal up. Otherwise, you're done. Thyroid hormone and insulin also promoting bone growth. So if you have a thyroid disorder, you could also have a disorder in bone growth. Estrogen and testosterone are going to also affect how bone grows. Testosterone makes bones more dense and so thicker and larger. And for females, it's going to also cause our bones to grow and widen at the pelvis. I'm laughing to myself because my one son, bones, forget it, they'll grow wider. A funny little story because my son, I guess when he was in 5th or 6th grade, was developing an eating disorder. He liked being very slender. He liked being able to put his hand around his wrist very easily. And so he, figured, I don't want to eat a lot because I want to stay like this. And I said, well, you're going to hit puberty and your bones are going to grow and you're going to get bigger. So, that's going to be out of your control unless we remove your testes and you don't make testosterone. I said, is that something you wanted to pursue? And he didn't. So he's definitely a full-size young man with big old bones. All right. And then, as I also said, that lovely little estrogen. Where am I? Where's my pen? Okay. That lovely little estrogen will cause your epiphyseal plate to close sooner than later. We'll take it. If that means, other things happen, I'm okay. So we'll have that bone growth. We'll have that bone. I don't know why I have this bone resorption in here. I've already talked about the fact that osteoclasts do this. They dig up little grooves. They break it down and then they die. That's what this osteoclasts undergo. I like to call it apoptosis because that's a lot more fun of a word to say, but it's called apoptosis. And I'm going to save this little comment for later because there is a hormone that will stimulate osteoclast activity. But we're going to go into the details on that in a separate lecture, not in this one. All right. So the other thing I wanted to say is I already kind of talked about this. What is going on with your bones in terms of mechanical action? You know, lifting, bone stresses. Bones are going to reflect the stresses they encounter. So if you're all changed your job, or you're doing heavy lifting, or you're doing weight bearing exercises, you're stressing your bones, you're going to make your bones thicker. Okay. Bones are stressed when weight bears on them or muscles pull on them. And it's, so when we look at this bone, this is a femur and this is the head. So if you're doing heavy lifting and you're putting on the stresses, it's, compression here, tension on the outside, compression on the inside. I am going to end up building bone thickness. And bones have all these crazy knobby ends and thick areas and lumps and bumps if they're weight bearing in response to stresses. So my words, so this is just more. Bone will grow in response to demands placed on it or demands removed. So if you look here, this is a tennis player and this is bone, right? So this is not muscle, and she's got her serving arm and her non-serving arm. Where is my pen? Okay. So on the left here is a serving arm and on the right is the non-serving arm, and it's showing you the serving arm humerus is going to make a thicker bone because of that constant whomp activity of to counteract the stress. So it's definitely proven that these mechanical stresses will make bone stronger and thicker. It's going to be thickest where you might bend or break it. And even spongy bone forms lines of support where there is stress. So even like I already said, you get these wacky bony projections where heavy duty muscles attach to it. But a fetus or people who are bedridden, that meaning there's no demands, their bones are going to be fragile, thinner, not heavy duty, I guess is what I wanted to say. This is just kind of cool. I'm not going to talk too much about this, but what causes bone to grow is when the bone becomes stressed, it causes ions to move differently, and I get this electrical signals produced, and they're oppositely charged, so I will have osteoblasts coming in. That's kind of like the alarm to an osteoblast, are these electrical signals. I just think it's kind of cool, and it's all with that communication within those canaliculi as the stimulus to then ultimately stimulate those osteoblasts in the periosteum. I just like it. It's just like, hey, why is that even happening? So that was what it was saying here. Compression is going to be an opposite response to tension, and it'll thicken it up one way or another to prevent bone fracture. Oh, that's not our next topic. It is in your book, but I've changed it in the lecture. I think we should stop. Let me see. Oh, you know what? I'm just gonna go live. Let's stop there. I could talk about this stuff forever because it's just fun to me. I love the little fun story. But I will come back, and our next lecture will probably be about bones activity in calcium homeostasis, because that was the next slide, and some bone fracture and repair. And then we'll just see what time it is. Maybe we'll just wrap everything up in the next lecture and be only 5 lectures. Okay. See you at the next time. Bye for now.